Okay, hello everybody. Welcome back once again. This is Chris Pliley, your Mat 235 professor, and I'm here to talk you through some of the material from chapter 2.4. In 2.3, remember, we talked about measures of center, in particular things like mean, median, and mode, and how we use those to determine where the center of our data lies. But now we want to move on to something else. Knowing the center of the data is not quite enough to fully understand it, and we move on to studying what we call measures of variation. And in particular, we talk about the muy importante concept of standard deviation. The root word in standard deviation, deviate. And so standard deviation really is just a measure of how much our data tends to deviate or disperse or spread. Okay. And so for today, we have one and only one goal. We're really just going to focus on number one up here. And our objective for this short video is just to see if we can try to make sure that we understand the interpretation of standard deviation as a measure of this spread or variation, right? If we can get an intuitive grasp of this concept, then we'll consider that a big success. And then once we're done with that, we'll start moving on to the formula for standard deviation, which can be a bit of a challenge at first for some students because it looks intimidating. But if we build this intuitive understanding of what it means first, hopefully it'll help us along the way. Okay, so what is standard deviation or variance about in general? So let's take an example here, a nice simple thought experiment, and let's think about three banks that are popular on this island. We have Banco Popular, First Bank, and my bank, Scotiabank. And let's suppose that I conducted an observation. I went into the bank one day and I looked and counted the number of minutes that it took the first three customers to be served at each of these banks. So at Banco Popular, my first customer had to wait 6 minutes, my second waited 6 minutes, as did my third. At First Bank, my first waited 4, my second two customers waited 7 minutes, and at Scotiabank, my first customer waited 1 minute, my second waited 3, and the final customer had to wait 14 minutes before they got service. So to start off, just to warm up, why don't you try this if you haven't done it already? So go ahead and find what is the mean waiting time for customers at each of these three banks. I'll pause the video, take a minute, and go ahead and do it. So did you go ahead and find it? If you did successfully, you would have found, well, the First Bank, the mean time is kind of obvious, 666. Everybody waited 6 minutes, so if I add that up, 6 plus 6 plus 6 is 18, divided by 3 is 6. And so in actual fact, at all three banks, if you went ahead and did the calculation, the mean waiting time for all of the banks was 6 minutes. So it didn't matter which bank I went to, the average wait time was the same. But you can look at what happened here, and you can already tell that a very different experience was sort of had by customers at different banks. And these represent three different sort of sets of data. Now, they don't vary in their mean or their measure of center, but they vary in different ways. And if I look at graphs of these three, visual representations of these three data sets, here I have Banco Popular on the left, where you can see that all of my customers waited 6 minutes, and across the board, I have no deviation or no variation from the mean. Everybody waited the exact same amount of time as was my mean. And if I look at my second bank here, which was First Bank, excuse my poor handwriting as usual, then we notice that there was a little bit of variation from the mean, but by and large, customers tended to wait around 6 minutes. This red line here represents the 6 minute mark, and you can see my first customer was a little bit below and my next two were a little bit above. Whereas at Scotiabank, of course, Scotiabank is a bit special and they do everything a little bit different, don't they? They had the largest variation from the mean. You can see my first customer waited well below 6 minutes, my last customer waited well above 6 minutes. And so the correct way to describe the difference between these three small sets of data is not to use mean. They have the same mean, but we need to find a way to describe this difference that we clearly see. Find a way to describe how different data sets can exhibit different amounts of dispersion or spread. And the right way to capture that is to start thinking about this idea as how far away from the mean does my data tend to be? Does my data tend to be very close to the mean, somewhat close to the mean, or very far from the mean? And that's what studying dispersion is all about. And so our standard deviation really is just a measure that we use to quantify the amount of variation or dispersion that we actually see in our data set. You can see with this graph here on the left, you could reasonably suspect that two data sets like this might have the same mean somewhere in the middle here or somewhere in the middle here. But you see more variation in this graph on the right in this histogram here than as opposed to this one on the left. So we would say this has more variation, and as we'll come to see, this means that it will have a higher standard deviation. A lower standard deviation, like we would see over here, indicates less variation, which basically just means that data points tend to be closer to the mean than on this other set. If I were to pick randomly a data point from these two different data sets represented here, there's a higher likelihood that my data point would be close to the mean if I chose from this set. Conversely, if I picked a point from here, there's a higher likelihood I might get a point that ends up being further away from the mean. And this is the same idea we see with our bank example. If I go into Scotiabank, there's a higher chance that I'll end up waiting either a lot longer than 6 minutes or a lot less than 6 minutes. Whereas if I go into Banco Popular, then I'm all but guaranteed to wait a much closer time to 6 minutes. And so to even further grasp this idea, let's think about what standard deviation actually will measure. And to do that, we're going to measure something very similar, but not quite standard deviation, and that's average distance from the mean. So suppose I ask you this question. Here's the wait times for our three banks over here on the left, Banco Popular, First Bank, and Scotiabank, remembering that the mean time for each bank is 6 minutes. So if I asked you this, if I said for each of these three banks, what was the average distance from the mean of 6 minutes, of the three wait times? In other words, how much more or less on average did the customers have to wait than 6 minutes when they went to the bank? So if I were to answer this question, well, what I would have to do, I'll do the first one here so you understand what I mean, and then maybe you can do the other two before you go on. So if I take Banco Popular, for example, I have three customers that each waited 6 minutes. So the distance between their waiting time and our mean time of 6 minutes is 0, 0, and 0. 6 minus 6 is 0. In other words, our customers had no difference in their wait time and the mean waiting time. And so the average of these three numbers here, 0 plus 0 plus 0 over 3, is just 0. And what that means is just a quantification of our observation that at Banco Popular, the data points had no difference from the mean. So what about the other two banks? Can you finish them? I'll give you a chance to do them now. What is the average distance from 6 for the customers in Scotia and First Bank? And so, did you finish? Did you finish it? At First Bank, we had customers who waited 4 minutes, 7 minutes, and 7 minutes. And the distance from their 6-minute mean was 2 minutes, 1 minute, and 1 minute respectively. This is just the difference, 6 minus 4, 7 minus 6, 7 minus 6. And so if I average the distance from 6 of these customers, they waited an average of 1.3 minutes, either above or below 6 minutes. At Scotiabank, of course, Scotiabank was all over the place. And so, did you do it? Did you find the average waiting time, distance from the mean for each of these other two banks? At Banco Popular, we had 0 minutes average distance from the mean waiting time. At First Bank, our customers waited 4 minutes, 7 minutes, and 7 minutes. So their distance from 6 minutes was 2 minutes, 1 minute, and 1 minute respectively. This is just 6 minus 4 and 7 minus 6 twice. And so the average of these three numbers, 2, 1, and 1, is 1.3. So at First Bank, customers waited an average of 1.3 minutes, either above or below that 6-minute average waiting time. And at Scotiabank, of course, things were a little bit more hectic there, and customers actually ended up waiting an average of 5.3 minutes, either above or below that 6-minute average waiting time. And so this idea of average distance from the mean is exactly what we sort of capture with standard deviation, albeit in a slightly different method and formula. But if you look at these three numbers on the right, this is a real key idea. I have 0, 1.3, and 5.3. And what I can think of these as measures of how much my data tended to vary, or how spread out my data was. The higher these numbers get, the more spread out my data was. If I have a higher likelihood of being further from the sort of center or mean of my data, then my data will be more spread out. And standard deviation measures the same thing. The higher the standard deviation is, the more spread out my data is. And standard deviation, the other beautiful thing about standard deviation is that if you notice these three numbers here, 0, 1.3 and 5.3, is that these are in minutes, right? This is the same data unit as my data points. 6 minutes, 0 minutes. And so what I can do is I can actually make conclusions that are very relevant and easy to understand. 1.3 isn't just some random number, it's 1.3 minutes. I can say things like, at First Bank, customers tended to wait about 1.3 minutes above or below 6 minutes. And standard deviation, although it has a little bit of a more complicated looking formula that you see down here on the left and the right, and we actually do a slight tweak to the formula, you might notice down here, depending on whether we are measuring the standard deviation of a population or a sample. We'll talk more about the formula and where it comes from in our next video, but for now, just remember this very important idea that standard deviation measures how far away from the mean our data tends to be. And so did you figure it out? Did you figure out which class was class A? So the key marker here is to look at the different standard deviations. Of course, I see one class that had a standard deviation of 26, one that had a standard deviation of 8, and one that had a standard deviation of 16. And the key point to remember here is that higher standard deviation implies more spread. What was I writing there? That didn't make any sense. Higher standard deviation means more spread out. So if I just asked you which of these three histograms looks the most spread out, I'm pretty sure most of you would point to this one down here, B. And this is, of course, right. This is class A right here. A standard deviation of 26, that's 26 grade points. So that means that in some sense you can think about that as the average distance, the typical distance away from our mean of 46 that students tended to be was 26 grade points. That's way up here around 72%, or way down below it, right, at about 20%. And so students tended to be very, very far away from the mean in this particular case. What's the second most spread out of our classes? Is probably C here, right? So C is a little more clustered around 46. And if we look at the average distance from the mean, the average distance from 46, well, we do have a lot of students still up here in the 70s, 80s, 90s, 10s, 20s, and 30s. So this graph would be the second most spread out. And I would say that B then would have the smallest standard deviation, where our graph was most clustered around the mean of 26. So hopefully you understand that intuitive idea. If nothing else, make sure that you always remember two things about standard deviation. Number one, the higher the standard deviation is, the more spread out my data is. And number two, make sure you remember there is a real-world interpretation of this number of standard deviation. It's not a random measurement. It's not just some number that doesn't make sense. It is in the units of my data. So if I am measuring a mean score of 46, and 46 represents percent on a test, then I need to be able to understand that this 26 is also 26% or grade points or whatever. And it is to be interpreted as such. That's it for now. Thank you very much, and we'll talk more about the formula next time.